last week that we'd start today's class by doing one little sketch of trigonometry, just to finish off that bit for a little while. So we'll do one little trigonometry sketch. And then I have loads of things to do with loops today, just to basically develop our problem-solving skills. And also we can take a look at arrays and strings and processing, our first look at arrays and strings and processing. And that's what we'll do today. Oh yeah, a couple of other things. I'm going to give out your first assignment on Friday. You'll love it. It's kind of related to what we're doing today. So let's find a little processing sketch that we can just do, just to get us all started and in the frame of mind to write computer programs. Yeah, we'll try a simple enough one, okay? There's some complicated ones, we'll try a simple one, otherwise we'll be here all day. Let's try this one here. How about this one? A person flying a kite is released. Can you guys see that? Oh. Okay, so a person flying a kite has released 176 meters of string. The string makes an angle of 27 degrees with the ground. How high is the kite? How far away is the kite horizontally? So guys, will you solve that problem first on pen and paper, okay? And then we'll see if we can write a processing sketch that, just actually draws out the problem and solves the problem for us as well. I'll draw it in again a bit bigger over here. So the string makes an angle of 27 degrees. So 27 degrees there. And the person has released 176 meters of string. So there's 176 meters of string up to the kite. And the question you have to answer is, how high is the kite? So that's the thing we're trying to find there. So that's the opposite and that's the adjacent in that right angle triangle. So I can say that the sine of 27 is going to be equal to the opposite, which is what I'm looking for, over the hypotenuse, which is 176. Is that okay with everybody? Yeah. Everyone get that? So then you can multiply it out. So you go the sine of 27 multiplied by 176 is equal to the value that we're looking for. So I'll run that one. So 27, and we'll get the sine of that is that multiplied by. Did I press the right button there? I didn't press the wrong button. Not quite sure if I pressed the right button there. Let me clear that again. 27. Oh yeah, okay, so the sine of that multiplied by 176 is the value that we're looking for, which is 79. Did everyone get that? Yeah. Okay, so then the next question, we know this one here, that's 79. And then the next question is to calculate the horizontal distance, which is this side of the right angle triangle. So I can use the same, there's loads of ways to do that. How did you always do it? We'll do it two ways. Yeah, so that's one way to do it, right? So the hypotenuse, which is 176 to be squared, is equal to 79 to be squared plus a to be squared. So then we have 176 to be squared minus 79 to be squared is equals to a squared. Is that the way you did it? What's that? Sure thing. But if you do it this way, is this correct? Yeah. So I think this is one way to do it, okay? Using Pythagoras. And then the other way to do it is to use the cosine. So I can say that the cosine of 27 is equals to the adjacent over the hypotenuse, which is 176. Multiply both sides and we get the cosine of 27 times 176 is equals to the value that we're looking for. So there's the two ways to calculate it. And what side did you get? What answer did you get? 156?
57.
157. Is everybody clear on how to solve these trigonometry problems? Does anybody want to ask any questions? If I was to ask you a question like that in your exam, would everyone get 100% in it now? Yes. Excellent. Great. Will you write a processing sketch that draws that out and that does the calculation, just for some practice? So first of all, just in terms of how I solved this problem, the first thing I did was I went and declared some variables for all of the stuff that I know. So I know the length of the string, so I call that string length, and I went that's equals to 127. I know theta, which is the angle, 27. And then the stuff that I need to calculate, the k height, I have that as being the kite height. And then so I don't put anything in for that yet, because I'm going to need to calculate it. And k dist, I need to calculate it. And then because I'm going to draw this somewhere, I've just put in some variables here for the left-hand side of the sketch and the bottom of the sketch. So I'm going to draw the triangle. So then up in the setup method, the first thing I do is calculate the k height. Now we spent some time previously working out the algorithm for calculating this, and I realized that it's actually the sine of theta multiplied by the length of the string. Isn't it? Yeah. So we know that processing uses radians for its angles as opposed to degrees. So I use that function up there called radians, which is going to take the value that's in degrees and convert it to radians. Is that okay with everybody? How will it do that? How do we take an angle in degrees and make it in radians? What will we do? Divide by 180 and multiply by pi. So everybody write that down if you need to. That's how you convert from degrees to radians. You divide by 180 and you multiply by pi. Because there's 2 pi radians is 360 degrees. It's the same as dividing by 360 and multiplying by 2 pi. You can just divide by 180 and multiply by pi and you get the same answer. So that's how radians works. That's what it does. So that's my two values that I've calculated. So now I know the kite height and I know the kite distance. So we can do this as just let's just do this using the triangle call, okay? So triangle. Let's just set background 0 and stroke to be 255, and then we'll do triangle. So this takes the 6 vertices of the triangle. So let's first of all specify this point here. It's based on the variables that I've got up there. What's going to be the value of that point there? Looking at the variables that I have. It'll be left and bottom, okay? Doesn't really matter. You know, you might have different variables. So it'll be over, left, and down, bottom. Now, let's pick the next line, which is going to be this vertex here. So this is going to be over what?
Left plus k dist.
Yep, left plus k dist. Excellent. And then also the second parameter for that would be bottom. So k dist is the distance that I've calculated here, and I've used the I've used the cosine rule to solve that. So that's left there plus k dist is going to give me that point. And then this point here is going to be over
plus width and height.
Yep. But just say the x coordinate for this then is the same as the x coordinate for this, isn't it?
Yeah.
Is everybody happy with that? It's the same as the x coordinate for that. So it's going to be left plus k dist again. And then the y coordinate is going to be?
Bottom minus k height.
Yep, bottom minus k height. Cool. So let's just see if that works. Oh, forgot to set the size there. So there we go, there's my triangle. I'll just change the fill to be 0. And there's there's the triangle. Okay,
How
so
did you change the direction?
what's that?
How did you change the direction?
How did I change the direction? How do you mean?
But it's going that way rather than this way.
So it's just the coordinates that I calculated. If you look at how the coordinates are calculated, so the first parameter, the first is basically over left and down bottom. The second one then, because this is the x-axis, is going to be left plus distance to get the x-coordinate of this.
Yeah.
And then the y-coordinate of this, I'm subtracting the height to get, because my y goes up. Does that make sense?
Yeah, but your triangle is going the opposite direction.
Is it?
Your angle's on the other side. Why would that?
It's the same as that one, no?
You're incrementing the x, so why is it going to the left?
It's not starting at the center.
I'm not starting
Oh,
at the
right.
center. Yeah, I just use left and bottom, those two
Oh,
variables to control the coordinates of the left-hand side of the triangle. Is that alright?
Yeah.
You sure? Yeah. Is that okay with everybody? Can you see how I calculated those three vertices? Is everybody happy with that? So maybe we'll just put in some text to show these values. And the first thing maybe I'll put in is I'll put in the angle. So, text. So this takes the string first of all. Okay, so the first thing I want to print is the angle, and the angle is theta. And then the x and y coordinates where I want it printed. So it's going to be probably somewhere like left and bottom, but maybe over a little bit from left and up a little bit from bottom, because I want it to be kind of inside the angle. Do you know what I mean? So let's try left plus 10 and bottom minus 10 and see if that works. What's that? No, if we put it in quotes, it will... Okay, so there it is. And in actual fact, one thing I just realized is that that text command actually uses the fill color. So there's that angle there. It's kind of alright. Over 10. Maybe I'll try and move it down a little bit. Cool, that'll do fine. So then let's put in some other text. Let's put in some text for this, which is the opposite side.
So how does the text amount work? What are the parameters?
So the first parameter is the text that you want to print, the string, and then the second parameter is where you want it printed, so the x and y coordinates. It looks like the y coordinate is actually the bottom of the text. And then the x coordinate, I think, is the extreme left of the text. Is that correct?
The left bottom? Or
What's that?
but I feel like if you change that bottom, like say the 10 tablets, I mean, longer.
It would be down further. No, it's actually not the size of it, but it's the coordinates where you want to print it. So let's put in some text for the other one. So the opposite side is going to be k height. And let's put this as this is going to be over left plus k dist. Let's say over bottom.
Do you need that plus symbol there?
What's that?
Do you need that plus symbol on k height?
Yeah, I'll tell you why in a second, right? Let's say that's going to be minus 50 for the hell of it. Just see if that goes sort of roughly in the right place. So there's the opposite side there. Can anyone tell me what's happening here? What's happening there? Look at that, opposite string plus k height. What's happening there? We are concatenating two strings. Remember when you're doing strings, the plus symbol means concatenation. And what will happen there is it will convert the float to a string and then append them as a string. That's how Java does strings. It does them kind of differently to C. So then let's put in the adjacent. Is that the way you spell adjacent?
Yeah.
We'll check it out in a minute. So the adjacent is going to be k dist. And then that's going to be left plus, just say left plus 50. Really it should be half. It should be actually left plus k dist divided by 2. And And in fact, this bottom minus 50 should be, because we want it to maybe go halfway, it should be bottom minus k height divided by 2. That makes
You
a
don't
bit
have a
more
plus
sense.
there on the left.
What's that?
On the left K list, you don't have a plus.
Sure, so that should be plus. And let's say bottom plus 10. So it'll go slightly underneath the line. There's the adjacent, there's the opposite, there's the angle. You know, the nice thing about doing our sketch like this is that I could change the string length to be maybe 300. And then the sketch will go recalculate everything and put different values in. Hopefully everything will just be, you know, just have done the calculations differently. Alrighty, is that okay with everybody? Does everybody know how to solve those problems now? And could you guys construct an algorithm to draw a sketch based on a mathematical problem like that? What do you think? Everybody? Is there anything else that you want me to talk about in terms of this sketch here? Okay, how are we doing for time? Because let's do the next one. It's just 11 o'clock. Let's take a 5-minute break and we'll do the next thing, which is actually more loop based, right? And here's a few things you guys already know how to do. It should be easy to write a program. Yeah, let's say I take this number here. And I want to know how the computer stores that number. It's going to store it in binary, isn't it? So there'll be a sequence of 1s and 0s. What's that number in binary, or how would I know what that number in binary is? I'm sure you did this last year. What's the strategy for converting a decimal number to binary? Do you remember? Divide by 2, and you take the remainder is either going to be 1 or 0, and then you read from the bottom up, and that gives you the number of binary. Isn't that right? Do you remember that? Okay, so it's kind of good to get used to thinking about numbers and how computers store numbers. Anyway, the strategy or the algorithm for that is we take that number, divide by 2. 2 into 18 is 9, and the remainder is 0. 2 into 9 is 4 times and 1 remainder. 2 into 4 goes twice and 0 remainder. 2 into 2 goes once and 0 remainder. 2 into 1 goes 0 times and 1 remainder. And we read from the bottom up. 1, 0, 0, 1, 0. So that's the number 18 in binary, isn't it? You guys did these kind of problems before?
Yeah.
Alrighty. How would I know, how would I verify that this is in fact the number 18?
Reading from left to right each time each one a bit value, and then
Got it.
once they total up to 18.
Sure
First
thing.
one
So
is-
if I was to take that number there, that number is what?
1,
That's the 1 column. This is the
2,
2's column.
4,
4,
8.
8, and 16. So we can add them up. So that's going to be 16 plus 2 is 18. So I've managed to convert from decimal to binary and then back to decimal again. Are you all very confident at solving these kind of problems? Everybody 100% clear on that algorithm?
Would it be mod to be using?
What's that?
Would it be mod to be using?
You could use, yeah, absolutely you could use mod, definitely, yeah. So here's the thing, right? If I give you any decimal number, if I was to give you the number 58, what I would suggest before you write the program to do this, what you want to do is just make sure that you're clear on the algorithm. So maybe just do a few of these little problems. Well, I guess you know the algorithm, okay? The next thing we want to do is we want to write a processing sketch. And in this processing sketch, we're not going to do any drawing. But what I want to do is make a function in processing that allows us to pass in the number as a decimal value and get out the value as a string with the sequence of 1s and 0s in it. Does that sound reasonable? And we want to return it. So, in terms of the signature of the method, what would the method signature look like? It might look something like this. Decimal to binary. And it's going to take one parameter, which is going to be an int. And let's just call that int DEC for decimal. And it's going to return a string. Like this. And in there I'm going to do some process. And I'm going to return the string out of it. So just to be clear about how we do the string thing, because that's the only bit that maybe might be slightly, new. Other than that, it's just going to be a loop which you're already familiar with. I can just go string or for return value is equals to the empty string like that, and at the very end I'm going to go return or. Okay, and then some bit in here is going to do that calculation using, what would you think? Yes, maths, but what kind of thing will go in there? Modulus, probably. We'll have some modulus. Most importantly, what am I going to do? I'm going to repeat stuff. And in order to repeat things, what do we use? Loops. So I'll have some sort of a loop in there that's doing something.
Could you use an int string? An int what's it called? Array.
An int array.
Yeah.
You wouldn't need to.
To return
What we'll
an
do
int
is, sure thing, but let's just return
then
a
you don't
string.
want slides.
We'll just return a string, right? And the string will have, you know, the sequence of answers. So say 1, 0, 0, 1, 0, like that. So it'll be a string with this format here. And we know how to append strings, don't we? Just use plus to append things to strings.
You have to declare a size of the string in this.
No, you don't, because the string will just grow. Anytime we append something, the string grows. It's not like an array in Java.
Also, something like, or net growing, does it, you know, something already taking up that memory.
We don't need to worry about it. Processing, or the Java underlying runtime will look after all of that. Unless our string becomes ridiculously big, in which case we may run out of memory, but it's not likely to happen for this sketch. Does anybody want to ask any more questions about this problem before we attempt to solve it? Alrighty. So what I'd say is this is the kind of thing you probably need to think about a little bit before you go write the program. But when you do come to write the program, just to prove to you that it's going to be just a simple little program, I'll show you, because I've done all of these last night. I did loads of them. So there's my decimal to binary code.
Sorry, can I just interrupt just for a second to
Yeah, can you give me 5 minutes or just a minute, or maybe a couple of minutes, or just
Yeah,
a
will we
minute
pop back in a
explain
few?
something?
No problem.
If you can just even hang on for a couple of minutes,
Yeah,
right?
we'll go to one of the other classes and come back.
Okay, sure thing. Yeah. So okay, there's a decimal to binary. I'm passing in 16, and you can see I'm printing out there. So when I run this sketch, that's a nice thing. That's a different thing. It's a cool thing that we'll get to in a minute. There it is. That's it. I don't want you to see the answer. Anyway, just trust me, it works. And there's a little loop in there that's solving that. Will you try and solve it? I don't know, you tell me. Actually, that's a good question. What would be the right type of a loop to use for this example? A for loop or a while loop? I'll let you guys think about it. Remember the rule of thumb for loops. We use a while loop if we're not too sure how many times we have to go through the loop, and a for loop if we know exactly how many times we want to go through it. So think about what needs to happen each time in the loop, and go and write a program to do that, will you?
Yeah. I think the language blew yet.
A little bit, yeah, it's great.
I love the, you can put like 4 things in a line, comes in between this equals 2, it equals a number at the end.
Right.
I spent my whole time trying to get
Oh, yeah, cool.
I love
Yeah,
that.
it's nice. There's lots of things like that they're doing. Yeah. I haven't done that much different programming. Okay, how many people have it working but printing the thing in the wrong order? Okay, how many people have it working completely? How many people are still working or not too sure? Just put up your hands just so I kind of know. Alright, watch what I do here, okay? Because we'll do the opposite to this, and then I'll give you a chance to try a couple of other problems like this. So, like, let's think really clear about the algorithm. What am I doing? I'm taking this number and I'm dividing it by 2. And the first thing I need to know is when do I stop? I stop when the number I'm dividing by 2 is equals to 0. Does everybody see that? So I'm going to divide by 2, and when that number is equal to 0, I stop. So I don't need an extra variable. I can just use the variable d, because this is always passed by value. So this is not going to change the parameter that's passed in. I can just write while d is not equals to 0. Okay, and then I'm going to do something. Alright, so is everybody clear about that? I'm going to keep on going and do something until d becomes 0. When d is 0, I jump out. But what do I need to do to d each time around? First of all, I need to check to see when I divide d by 2, is it a 0 or a 1? So there's loads of ways to do that, but here's a simple thing I could do. I could just go the return value equals the return value plus, in fact, this is slightly wrong, the D value percentage 2. Alright, I'll just do this the wrong way and then we'll actually fix it. Okay? And then I need to divide D by 2. So D equals D divided by 2. That's kind of nearly it, right? So I'm going to keep on going until D is equals to 0. Each time around, I'm going to divide by 2, get the remainder. That's what that's doing. It's not changing the value of D in the first place there. But if the remainder is 0, I'm going to add a 0. If the remainder is 1, I'm going to add a 1. Does everybody kind of see that? The step-by-step bit? Alright, so the problem here is what? It's going to print it in the wrong order, isn't it? So if I do 16 for that one there, and if I run this sketch, I will see that in fact it's kind of nearly there. You know, the one is correct. So I've got 0, 0, 0, 1, but it's the wrong way around. So the way to fix that is, and if you look at this, it's actually really easy to fix, right? There's loads of ways you could fix it. You could write another loop to flip each of the characters in the string. But a much better way is to just look at that line, ret equals ret plus D percentage 2. So where is that going to put the characters? It's going to put them at the end of the string. Alright, so it's going to take the old value of ret and it's going to append something to the end of it. So a better way to do it will be to try and stick that in at the start. Alright, so in order to do that, we just take this here and go ret equals that plus ret. So what that will do is it will actually insert the new characters in at the start instead of at the end. And that's the problem solved. Now it's interesting to observe what happens here, right? Let's imagine we have the number 2, right? Very simply, what happens? 2 gets passed in, D is not equals to 0, so then I go ret equals D percentage 2, so D percentage 2 is going to be 0 plus ret, and ret's already 0, so it becomes 0. So that's the string. And then I go D equals D percentage 2. So D equals D divided by 2. So that's going to be D divided by 2 is equals to 1, isn't it? Yep. Alright, so D now becomes the value of 1. So I come back in here, D is not equals to 0. So then I go ret equals D percentage 2 plus ret. So D percentage 2 this time is going to be, so 1 divided by 2, remainder. So 2 goes into 1, 0 times, and the remainder is 1. So then we look and see where is it going to put it. So I take the old value, so it actually puts the 1 at the beginning. So it's going to take the existing value for this, which is 0, and it's going to insert it at the beginning. And then D equals D divided by 2, so then that's going to be equals to 0, and then I jump out. Does everybody see that? Does that make sense now? Okay, so what was the algorithm that I used in my head? First thing I thought of was, what causes the loop to terminate? And that's the first thing that I looked at, and I wrote a while loop, and I said, okay, it causes it to terminate whenever D becomes 0. So therefore, that's the first thing that I wrote. And then the next thing I thought of was, what do I need to do each time around inside the loop? And then I was able to construct the loop.
What if you put 0 in? You wouldn't need anything back.
What's that?
You wouldn't need anything back if you put in 0.
Yeah, you're right.
They want 0 back.
Of course. You would want 0 back.
That won't give you 0, that would give you nothing.
You're absolutely right. So maybe I need to put a special case in there for 0. Good point. Okay, should we try the other way around? The other way around is taking a string of characters and converting it to a decimal number. How are we doing for time? Plenty of time.
This is just I was just wondering how yours was printed.
Okay. I actually thought we'd get a little bit further today, but this is okay.
So binary decimal next.
Yeah, let's try binary to decimal. We'll try it as a string instead, right? So let's think about how we do the binary to decimal. Let's imagine I have a string, and I need to show you a couple of little simple things with strings. First of all, the method's going to look like this. It will be int bin to decimal, and I'm going to pass in a string. So yeah. So the one thing I need to show you, this is actually slightly easier one. There's a couple of things. First of all, to get something to the power of something else in processing, you use POW, which just stands for power. And if I want to get 2 to the power of something, that's going to return me 2 to the power of 3. So 2 to the power of 3 is what? 2 multiplied by 2 multiplied by 2, so it's going to be 8. So the first number is the... What's this number? What's this called? This is called the exponent, isn't it?
Base.
Is it the base? I don't think it's the base.
2 would be the base.
Not really too sure. I'm not sure what you call that number there. This is the exponent. It's the thing that you're going to raise it to the power of. That's how you do power. The next thing, to get access to individual characters inside a string. If you have something like string or ing s, okay, and s is equals to the string b or y a n like this. If you wanted to get access to this character by character, you can do char c is equals to s dot char at. So it's s dot char at, right? And then you pass in the character you're looking at. So if you pass in 1 there, you're going to get the character. You get the character or. Because the character, they're indexed from 0, like arrays. So that's 0, 1, 2, 3, 4. So that's how you get a character at. The next thing, to get the length of the string, it's s dot length, L-E-N-G-T-H. Open, close brackets like that.
Put anything in the brackets, do you get anything?
I think it won't compile. Alright, so s.length will return you the length of the number of characters in the string. s.charAt will give you a character at a particular location in a string. So see if you can write that function bin to decimal, pass in a string and return the decimal value of it. Alrighty. It's going to be a very strange video for today. Lots of stopping and starting. So I might write something like this. For int I equals 0, semicolon I is less than bin dot length, like that.
Minus 1.
What's that?
Bin dot length minus 1.
Y minus 1.
Because the arrays go from 0 up.
Sure thing, but I'm stopping once bin, I'm going less than bin dot length, so I'm not going to go up as far as
Don't you want to start at the end?
What's that?
Start.
Yeah, actually maybe it doesn't really make a huge difference, right? Because I can do it this way or I can do it the other way.
Okay.
You know, you can write your for loop to go from start to the end or the end to the start. Okay, so here's my characters, right? So that's me writing a for loop. It's going to start at this character, then do this character, this character, this character, and then this character. Okay, so I can get the character out just by going char c is going to be equals to bin dot char at, like that. So that's going to give me the character. So the character in our case would be either a 1 or a 0. And yeah, this again is a kind of a new thing. Alright, so what's going to happen here is char at is a method that we're calling on this bin, which is an object in Java. And this is going to tell me the character that's at position I, the single character. And then I need to go, first of all, probably ret equals 0 to give it an initial value. So, what do I raise it to the power of?
String length minus I.
Yeah, it's going to be kind of length minus I, isn't it? Kind of bin dot length minus 1 minus I, isn't it? Can I write that a nicer way? That looks pretty horrible.
Why would you go minus 5?
Because I need to do it in the opposite way around. So let me think about this for a sec, right? Because I actually realized I had a bug in my solution that I wrote today, so this is probably correct. So let's say we have these. This is going to be to the power of, this is going to be 2 to the power of 0, 1, 2, 3, 4. And then the string length is going to be 4. 1, 2, 3, 4, 5. So I'm looking at character number 0 on the string. It's going to be this one. And I need to take that multiplied by 2 to the power of 4. So length is going to be 5. So minus 1. Length minus 1 is going to give me 4. Minus I, which is going to give me 0. So that's going to be to the power of 4. For the 0th character. So I think that's it. Is that correct? What do you guys think? Look up at what I've written there and see if it makes sense.
I don't understand how you do it with the power.
What's that?
I don't understand how you do that with the power.
So power, the first number in pow is the base, and then the second number is the thing you're raising it to the power of. So let's think about, okay, this string here has got 1, 2, 3, 4, 5 characters in it.
Yeah.
Okay, this one here is going to be to the power of 4. This is going to be to the power of 3. This is to the power of 2, to the power of 1, and 2 to the power of 0. Does that make sense? Is that okay?
Yeah.
So then, when I'm looking at the 0th character, that's the 0th character in the string. That needs to be to the power of 4. So how do I get 4? So I'm going to take a bin.length minus 1, which is going to be 4, minus I. So I starts out at 0, so it's going to be 4 minus 0, so it's going to be 4. Then they're going to take 4 minus 1, which is going to be 3, 4 minus 2, 4 minus 1, 4 minus... I think that's it.
Yeah, no, but you're going to be multiplying zeros as well.
Huh?
You have the base hard coded.
The 2, you mean?
So you need to miss the bracket.
Oh yeah, missed the bracket, yeah.
But you're also going to be multiplying zeros. Where you should only be multiplying when there's on a 1.
Oh yeah, you're right, of course.
You have to go leave 0.
What about that? Does that look a bit better?
Why are you returning 0?
Yeah, I don't want to return 0, I want to return red.
Yeah.
It kind of looks a bit better. Let me just make sure that that works, right? Let's try the string 1, 0, which is going to be 2.
So have
Hooray! And then we'll try 1, 1, which is going to be 3. 1, 1, 1, which is going to be 1 plus 2 is 3, plus 4 is 7. There we go. So I think it kind of works. I bet there's a nicer way to write that. That looks kind of ugly. Well, yeah, there's solutions to a lot of these on the website, but don't look at them because they've got mistakes in them. I wrote them last night, and I just realised there's a couple of mistakes in them. So I'll put some solutions up. Will everybody take a quick look at that before we finish, and just make sure you understand what I'm doing. What's that? That's the answer to... oh, that one. Well, we can work it out. It's 1, 2, 4, 8. So it's going to be 9. Should be 9. You might come up with another solution to that, okay? So tomorrow's lab, actually I'll just show you this because I think it's rather cool. As a lot of your labs they're actually very cool. Here's your lab for tomorrow. And this I'm going to get you to make use of a Boolean array, okay? But just have a look at this. And here's a big sequence of spaces where you can click, and you can click these, and when you click them, it will give you the value of the number in binary at the top there, or give it to you in decimal at the top. And you can turn on and turn off these bits. But I actually think, looking at it, it's got a fatal flaw. It's the wrong way around, isn't it? So I'll have to fix that. And that'll hopefully be your lab tomorrow. Okay, have a great day, everybody.